When DNA molecule containing thymine dimers are replicated, gaps are formed in nascent complementary strands opposite the dimers because the DNA polymerase cannot use the distorted strands as templates. After a lag due to the thymine dimer blockage, replication is reinitiated at the second initiation site beyond the dimer. This results in progeny double helices with thymine dimers in one strand and gaps in the complementary strand. If these sister chromosomes recombine such that the dimers and gaps end up in one chromosome and the intact, undamaged segments end up in other chromosome, the latter will be functional and produce a viable cell or a DNA. DNA repair mechanisms similar to those described for E. coli have also been demonstrated in humans in studies done with cell cultures. In addition, their existence is indicated by genetic studies on individuals with sensitivity to mutagenic agents such as UV light or ionizing radiations. Therefore, the pyrimidine dimers may be formed and repaired not only in UV irradiated bacteria but also in skin cells of people exposed to unfiltered sunlight. The best known example of an inherited deficiency in the repair of radiation damage in humans is the autosomal recessive disease called Xeroderma pigmentosum. The enzymatic repair mechanism for UV damage is genetically defective in this disease. What is Xeroderma pigmentosum? The symptoms of this disease. The skin and lips of the diseased individuals exhibits extreme sensitivity to sunlight. That is, they may have skin burns and also cause hair to fall out, resulting in a high frequency of tumors in epidermal cells of exposed areas such as the face. The skin becomes very dry and thick. The skin cells proliferate abnormally and the skin cancer may develop. This disease is often fatal unless the skin is carefully shielded from sunlight. Therefore, if you are exposed to UV light, you have to take some precautions. You have to wear gloves or you have to wear sunglasses. Otherwise, you may get this type of DNA damage. Biochemical and genetic research has revealed that in the most common forms of Xeroderma, the defective enzyme is the UV endonuclease required to nick the defective strand at the 5' side of the pyrimidine dimer. Some individuals with Xeroderma pigmentosum develop neurological abnormalities that appears to result from premature death of nerve cells. This effect on long-lived nerve cells has potentially very interesting implications on aging also. Some diseases like Fanconi's anemia, ataxia, telangiectasia, Bloom syndrome are the other three inherited diseases in humans in which the primary defect may be in the DNA repair pathway. All the conditions result in a high risk of malignancy, particularly leukemia in the case of Fanconi's anemia and also ataxia telangiectasia. Next is about the effects of ionizing radiations. The ionizing radiations include X-rays, gamma rays, cosmic rays, alpha, beta, and gamma particles, neutrons, etc. H.J. Muller was the scientist who first demonstrated the mutagenic effect of X-rays in 1927. Muller made many contributions to our understanding of basic genetics through his extensive research. He was awarded Nobel Prize in 1949. The high energy radiations or ionizing radiations produces a genetic alteration or mutation at a very low dose also. Ionizing radiations such as X-rays with a wavelength about 0.1 to 1 nanometer are of high energy and thus are useful for medical diagnosis because they can penetrate living tissues. It can also cause cancer on bone marrow and other sites. It has been shown experimentally that a low dose of X-ray, about 100 Roentgen, will destroy a large part of spermatozoa of male mammals, resulting in sterility. Similarly, there is a high level of risk if fertilization occurs within the few weeks after radiation exposure in human male. The human female is more sensitive than the male in consequence with the effect of radiation in the germ cells because it has been shown experimentally that mature oocytes is particularly vulnerable to radiation.